we are looking at worksheet Q, if that is okay with y'all. Worksheet Q. Someone flip the light switch down for me, please. That's good then. So, worksheet Q. Let's see some questions about worksheet Q.
4.
4?
All of it.
I heard 4. Okay, so we'll start with 4.
All of it.
All of it? I hope not. But, all right, number 4. You have, says a gardener plans to use a 1,200-foot roll of fencing. So they have 1,200 feet of some sort of fencing. So that's like your perimeter, your distance all the way around. To garden plots, splitting a rectangular enclosure in half. So you have that. Give an expression for the entire length of the garden. Okay, so this distance right here is the length. Agree? So let's think about this. So it is a rectangle, but things are goofy with this rectangle. So I know I would have a top and a bottom to this rectangle, so I have 2 lengths. Agree? How many widths do I really have?
3.
3. Does that make sense? And I know that the perimeter of a rectangle isn't 2L plus 3W. Okay, I know that. But we have 3 of the widths that are taking place because that's basically our width. So we have 3 of them. Is that okay so far? So let's put in what we know. I know 1,200 equals 2L plus 3X. Good so far? So we're using the perimeter equation to get to solve the variable for L. So I'm going to go 1,200 minus 3x over 2 is equal to L. Does anyone need me to explain how I got that using algebra? Subtracted 3x, right? Divided by 2 gets L by itself. We good? Yeah. Happy enough? All right, so then, in order to find the area of this shape, it doesn't matter how many x's I have, it's just length times width. Well, I know that the length, we're going to say, is 1,200 minus 3x over 2. Excuse me. And the width is just x. Is that okay? Mm-hmm. Now, I could get all cutesy. I could go and distribute 3 or x over the parentheses, but there's no reason to. Now let's go to our calculator. So 1,200 minus 3x. Oops, go here, go here. I'm going to do this. I'm going to go y equals. Let's clear that out. Go up to my stat plot. Turn that off. Go back down here. And I just forgot what I had. 1,200 minus 3x over 2. So I have 1,200 divided by 2 minus 3x divided by 2. Let's clear that. Let me change that. I'm going to change that just a little bit. 600 over 1.5x. 600 minus 1.5. X. And then my other thing is x. Okay. Why did I put 600 minus 1.5x? So I didn't have to deal with, so all I really did is I just did this. I said, broke this into 1,200 over 2, which is 600. Broke that into negative 3 over 2, which is negative 1.5 times x. Is that okay so far? And that, I have to, so give an expression with length. We already have that. Write the quadratic function for the area of the rectangle. It's right there. And what are the dimensions of the largest such enclosure? So what I'm going to do is I'm going to graph this. I'm going to find the vertex. And that should allow me to, so let's go to zoom fit, zoom 0. Whoa, zoom out. Need to start, zoom out again, zoom out again. All right, can I see my vertex? Sure. All right, so I'm going to go second, calculate. I want to find the maximum because it's the highest point. So I'm on the left side and the right side. So 200 comma 660,000. Is that right? So my vertex was this. So that's an x value, agreed? So that means that I would need each of these to be 200. And then if I wanted to find the length of it, my length equation is this. So 1200 minus 600 is 600 over 2. That's 300. If that's 300, that has to be 300. So I hope that adds up to 1200. So 300, 300, 600, and then another 600 is 1200. Yes. So my length, or my width needs to be 200. My length needs to be 300. And that'll give us the maximum amount of area, which is 60,000, I think, square feet. That's it. Next problem on Q.
2.
Where?
3.
3? 3. Oh, scented widgets. All right. Your factory produces lemon scented widgets. Your count tells you that the less it costs to produce each unit, the more it must cost to be produced. Then the more than you need to be produced. But she also tells you the cost will eventually go up if you make too many widgets because you will have to pay a storage by overstock. She says that the cost for producing X thousands of units a day is modeled by this function. Oh. Find the daily production level that will minimize your cost. Okay. Let's go here. So this is number 3. So C is equal to 0.04 x squared minus 8.5 x plus 25,302. Okay. Your count tells you that the less it costs to produce each unit, the more of them must be produced. Okay. Oh. So this is going to be a problem when we graph it. It's going to be basically this. So if I find the minimum or the vertex, the x component of the vertex will tell you how many to produce for a minimum cost. Does everyone know how to graph that parabola? Does anyone need to see me graph it? Okay. What else? Last question on Q. Five? 5 is done the exact same way as 4, except rather than having 3x, you have 4x. It's done the exact same way though, okay? If you still needed to see it worked out, let's take care of it tomorrow. But any others you want to take a look at? 2?
No? Or just kidding.
Graph the parabola. And then find...
I'm the wrong one.
I'm on Q.
I'm on Q.
Q. The number of mice in a field over years is modeled by the following quadratic.
I just don't understand. And I'm on 2. That's how far I've...
You're on letter Q.
I'm on... Yes.
That's the worksheet you're looking at currently.
Yeah. Oh
Okay, and number 2.
I'm looking at Q, right? Yeah. Never mind. You can move on. You can move on.
Thank you for your blessing. Any others you'd like to take a look at?
Number 8.
Number 8. Okay.
I mean, that's okay.
The sell right sells men's ties. Ties are $27 each. They have been selling 120 ties per week. Okay? All right. So that's 8. So right now, our revenue is going to be...
What?
It's our revenue. 27 times 120. If you have a calculator, someone tell me what that works out to, please. Do what? How much?
Oh, okay. I guess I'm doing this. 1 second. 27 times 120. to 800.
800. So that means this particular place on this selling this particular item is making this much revenue per week as far as the ties go. Okay? They might have other products. But then they have some consultant that says, hey, if it is determined that if you, for each $1.50 that you reduce your price, so what's my price of my ties right now?
27.
Right, so for 27, for every $1.50 that I reduce it, there's the first part of it. The company reduces the price, an additional 12 ties will be sold.
Oh, then you like trying to grab it.
I hate it.
Yeah.
I think the 27 comes from 4,240.
How much is it?
3,240.
This is 3,240. Okay.
Sister,
Yeah.
Who wants to know what you want for King Supers?
I'm good. Do what?
Whenever I try to graph something on my calculator, it says invalid DIM.
Dimensions, yeah. Your window's not big enough. So that's where you use your zoom fit. Zoom 0.
Okay.
Okay. Is your stat plot off? It. All right. So I'm going to graph this equation.
Oh. No, it's not.
Okay. So I'm going to graph this equation. So go up to here like that. Highlight that. Hit enter. It'll turn it off now.
Yeah.
All right. So my first equation was, oh, fiddlesticks. 27 minus 150x. 27 minus 1.5x. Close parentheses, open parentheses. 120 plus 12x. And then zoom fit. That looks all right. Maybe zoom it out a little bit. I just want to find my vertex. All right, so I'm going to go second calculate. I want to find a maximum. So I'm on the left side of it. Enter. On the right side of it. Enter, enter. So it looks like if I were to 435.28. 435.28. 435.28. All right. So if I were to if I were to sell, I don't want to say this. I can make $3,528 revenue if I raise the price of my ties by $4. Okay, so the tie would be $31 a tie. You're going to sell less ties because you did that, but you're going to increase your revenue to $35.28. So is that a big difference from $32.40, what you were doing, to $35.28? Maybe not for one individual store. Maybe it's not the world. But think about this. Let's go to, if we went to a store that was like nationwide, or let's say we were to go to Amazon, and Amazon does the same thing, and they have some tie they're trying to sell. Does that kind of figure make a difference for Amazon?
Yeah.
I mean, Amazon's big, right? Last I checked. So that could be millions more they're making in profit by increasing the price $4 per tie.
Wow.
I don't know. Might be something to think about, right? All right. Will you please make sure your name is on worksheet Q? Yes?
Yes, I wasn't here yesterday.
Yeah, you're a victim.
No.
Thank you.
You got it. Worksheet, you make sure, all I want right now is worksheet Q. And let's see, Angela, where you at? Angela back here. Pass it. Angela, jump. Pass that all the way back. Grant, over here. That's for you. So worksheet Q is all I wanted to have pass forward right now.
It's no Oh my god.
It was so unfortunate. So this guy got vacuumed, and then he got and then there was a through ball.
Uh-huh.
That's both of our center backs. So, and then a guy ran onto it.
You know, I
Right
feel a
back
lot
came across
from everyone.
the box and just fouled him. So this is too bad.
It used to be about.
Fun season for you guys, though, for sure.
Oh yeah.
No, it wasn't. It was good memory.
All right. Now let's go to, that was Q. Let's go to worksheet R, if you don't mind. Worksheet R.
No. Yeah.
Yes. Is that on R?
Yeah.
Where are you at? Which number? Oh, okay. So which one would you like to go? 6, 7, or 8? I think, I think number 6 is the most complex one, if you don't mind.
Yeah.
So it tells us, they tell us that standard form is this. Y equals 2x squared plus 16x plus 24, right? Okay, so I want to put this in vertex form. So if I put this in vertex form, means it's going to look like this. Is that correct? So that means I have to complete the square. Okay? So if I'm going to complete the square, and this is trickier because there's things that don't make sense to you. Right now we have y equals. It's not 0 equals, right? So first thing I'm going to do is I'm going to do this. Y over 2 equals x squared plus 8x, make a space. What did I do to everything? Divided everything by 2, right? Okay, so now I want to complete the square. Okay, so half of 8 is 4. 4 squared is 16. If I add 16, I have to subtract 16 from the same side. Does that make sense? So this right here is a perfect squared trinomial, which means that's going to become x plus 4 quantity squared minus 4, and then I still have y over 2 equals that. Agree? Now I need, of my 3 terms, I'm going to multiply this by 2, this by 2, and this by 2. So I'm going to get y equals 2 parentheses x plus 4 squared minus 2 times 4 is 8. And there's your vertex form. Is that okay? Now, being you've already done vertex form, let's go ahead, rather than going back to and factoring it, factoring your original, let's put this into factored form. So all I have to do here is I'm going to do this. This is why I actually think completing the square might be the best of all of them to solve. I don't like the quadratic formula because there's too many signs. Watch this. I want x by itself. All I did is I made y, made it 0. So I'm going to add 8 to both sides. Is that okay? Divide by 2. Root plus or minus 2 equals x plus 4. So then I'm going to get x is equal to negative 4 plus or minus 2, which is going to give me negative 2 and negative 6, which means x plus 2 and x plus 6 is our factored form. Do what? The answer. Oh, that was the answer. Yeah. So what we have to remember is this. This was here, so it has to come here. That doesn't affect the roots at all. Okay? Anything else off of R? 5?
5.
5. 5 was the one that was asked for. Okay. A couple of you are chatting too much. Number 5, we have this equals 1/3 x plus 2 x minus 4. All right, so let's just graph it so we can take a look at it. This is going to give me negative 2. This is going to give me positive 4. So halfway in between the two is 1. So I'm going to find my vertex. My vertex is 1 comma something. So 1 plus 2 is 3. 1 minus that is negative 3. So 1/3 of 3, what is it? 3 times 3 is 9. It's negative 3.
Oh. What? I got 3.
Yeah, I got negative 3.
Oh, wait, one
Yeah, if I plug 1 in, 1 plus 2. Guys and girls, I don't know what, there's way too much talking. And I know that we're not. So 1 plus 2 is 3. 1 minus 4 is negative 3. 3 times negative 3 is negative 9. 1/3 of negative 9 is negative 3. Okay, so this is, for the most part, what my parabola looks like. Okay, so then we can say, hey, what's the domain? The domain of all of our parabolas that we'll use is negative to positive infinity. There's a negative there. Our range is going to go from negative 3, because it's opening up to infinity, so elevator ride up. The roots as ordered pairs, 4 comma 0 and negative 2 comma 0. Those are my roots. Call it a root. Is that okay? Interval where it is increasing. It's going to be increasing right here. Okay, so we're going to use the increasing in the x direction. We're going to talk about it. So from 1 to infinity, and it's rounded, 1 to infinity, it's increasing. It's not a square bracket, because right at 1, it's actually constant. It's a horizontal line. So that's where it's increasing. And then, where is the function decrease? Thank you. That's a 0. Oh, dude, I will change that for you. I'm sorry about that. And where is it decreasing? It's decreasing over here. So then it's decreasing from negative infinity, and using the x direction of what's going on to 1. That's where it's decreasing. And then, does the function have a max or a min? Well, this is a minimum. What is the minimum? It is actually negative 3. And what is that value? The minimum is equal to negative 3. So you use the y value to discuss the minimum. And then where does this value occur? Yeah, it occurs at the vertex, which is 1 comma negative 3. So somehow, I don't really know how to answer that, but does it occur at 1? Yes. Okay, let's see.
And then it's 10, just like the other stuff on Q with the boxes.
I'm sorry?
Is 10 just like the other box one?
Hang on, I gotta take a roll real quick. Check the roll. Oh wait, don't go there. Go here. Go here. Okay, got Fiona out, looks like. Uh-oh, computer's speeding. Fiona's out. Ben here?
No.
Clay here?
Yeah.
Or Cooper here?
Why you falling asleep?
That it? We're good? We'll mark Riley absent just for fun.
Every time I see that picture,
10? Alright. Number 10. Number 10. A landscaper is creating a garden for a client. The garden will have 3 sections. 3 sections, 2 that are congruent on either side of the larger area. We'll have an area for the children and the family. The landscaper will fence the 3 areas. The garden will be attached to a garage, so no fencing will be needed on the side of the rectangular garden. Okay, a sketch is shown below. So we have this, for the most part. Let's just pretend I'm a really good artist. I don't need it here because that's the garage. Is that okay so far? All right, so so the garden will be attached to the garage. Okay, the landscaper has 120 feet of fencing. So right now they have a perimeter of this. So I have X, I have X, I have X, and I have X. Agree? So those are the widths. So we're going to say that the width is equal to X. And then I have a just a singleton length up here. I don't have to use the length against the garage because we're not going to put fencing along that, right? All right, so my perimeter equation is going to be L plus 4x. So that's 120 equals L plus 4x. I want to solve it for L, so I get 120 minus 4x. That's equal to L. Is that okay? And then from there, I want to find what is the algebraic for the indicated dashed line. All right, we got it. That's it right there. That's L. Write a quadratic that can maximize the area. So the quadratic is going to be this. So it's going to be area equals
120 minus 4x in parentheses and then x.
times x, just like that.
How do you get track?
You do it every day.
This is the first time I've done this in like 2 months. This is the first
Okay.
time I've ever done this.
So this is my quadratic formula right here off of that. I can then find I can graph the parabola, find the vertex. The x component of the vertex is this. So let's go ahead and graph it. 120 minus 4x. Zoom. Now I'm going to zoom that. I think we can see enough. I could start cutting stuff up. Basically, I'm just looking for the max. So second, max. I'm on the left side of it. Enter. Go to the right side of it. So I'm going to call that 15. Is that okay?
Yeah.
So 15 comma 900. 15 comma 900, that's my vertex. So that means my x values, these are each 15. And then my length is 60 right there. So 60 plus 15 plus 15 plus 15 plus 15 should give me 120. Okay, why do I not worry about this down here? Well, it's the side of the garage, right? Cool. I guess I have it backwards. They had the garage here and they had that the fence, but it's still gonna be the same. And then what value maximizes the area? So with my width of being 15, I have a area of 900 square feet. What are the dimensions of the garden? The maximum area. So 15 by 60 would give us the maximum area. Or let's see, wait a minute. Did they say? It says the garden will have 3 sections. Okay. Cool. All right. So, will you put your name on R and pass that one on forward?
Here's QA.
Is there a stable?
Just fold the corners.
You turned in Q already?
We turned in Q already.
I turned in Q not already.
All right. So, I'm going to hold off on S. I want to get these notes out.
Yeah, I'm a bully.
That's not true.
Oh, what are you gonna do? Hit me back? Okay, that was too far.
Homework.
Thank you.
Yeah, you need the skateboard.
I did Q not 2 not 3 on the shoulder. Or one out. Thank you.
Homework. Any more?
How was your Halloween?
I can bring you that too.
Yeah, but there's not very many trick-or-treaters.
We had 10 trick-or-treaters at a Halloween here.
Dude.
I don't know any of them.
All right. So, everyone have a notes?
It wasn't me passing out this time.
You still did quality wrong.
Let's just show you like Tic Tacs.
Yeah, thank you. Oh, they did. Sure did. All right. Ready? All right. So, ready? I'm going to just start flowing over on these notes. This is it. No, I'm good. Thank you. This is it. I'm going to hit S tomorrow. Go over it more tomorrow. Huh?
So do you see tonight?
Well, we're going to make sure S is done for tonight, but I just want to introduce this idea. I'm going to build upon this idea more tomorrow, okay? All right, so you all have done inequalities before, yes? So I'm going to bypass the two linear ones, and we're going to go to this one. Now, this is actually a poorly written problem because there's a value that is missing from our equation that says we don't graph it. Which value am I missing? I'm missing y. Bless you. I'm missing the y value. But yet I have an xy value grid or Cartesian plane up here that I'm going to try and graph off of, right? So I'm going to do this. I'm going to factor this. This is going to go x minus 4, x minus 2. Excuse me, that's a 2. Agree? Okay, so now, I'm going to show this without even graphing it on there. I'm going to say, I know that these 2 points are important to me. 2 and 4. Agreed? Those would be called our roots if this is y equals. Agree? Okay, we all right so far? So now, we want to have values that are less than 0. So what does less than 0 mean as far as values? Positive or negative?
Negative.
This means negative, right? We're going to deal with negative values. Does that make sense how I just said that? All right. So here we got to pick a color we haven't used in some time. Let's pick this hot pink. I like it. All right. So you have basically 2 critical values here so far. Yes? We have a 2, we have a 4. So this is what you want to know. You want to find out where this graph is negative. Okay? Want to find out where this graph is negative. So you're going to go to your furthest right root. So I'm going to come over to this region right here. Every value over here is going to be positive. Think about this. What does this parabola look like? It does this, correct? What is this? Where does this go? Positive, right? So if it goes positive, in between these is going to be negative, and then over on this side it's going to go back to positive. So if I had graphed this, it's going to look something like this. So we're showing, hey, it's positive here. Hey, it's negative here. Hey, it's positive here. But we're going to try and focus on only our signed line. And that's a big step because a lot of people are like, well, I can just graph it and see where it's positive. You're totally right. But we want to try and bend you away from that behavior because it starts taking too much time in pre-calc and calculus. Okay? So does everyone agree or everyone understand where this comes from? Now, technically, this is an open dot here and an open dot here. Why is that? Well, I don't have an equal sign. And what that actually starts coming to later with bigger functions is it creates something called an asymptote. And it could be a vertical or a horizontal asymptote. It can even be a slant asymptote, which is sometimes called an end behavior asymptote. Okay? But that right there, the plus minus plus with the 2 and the 4, with the open dots at the 2 and the 4, is the answer to this problem. Okay? Can I try another one? All right, so I'm going to ignore this for right now. I'm going to factor this. This is going to be x plus 5, x plus 6, when factored. I want greater than or equal to 0. Greater than or equal to 0 would be what? Could be closed, and would it be positive or negative? Positive. Okay, so we're looking for where it's positive. So at negative 6 and at negative 5, does everyone feel comfortable how I got those?
Yeah. Oh, so it's going to be pointing down.
Okay, so ready? Ready? This parabola opens up, so I'm going to start on the right. So is it positive over here or negative? Think about it. The parabola looks like that, right? The parabola looks like this. So it's positive. What's it here?
Negative.
What's it here? Positive. So it opens up. Okay? So if you wanted to, justify this answer, you could say from negative infinity to -6, and from -5 to infinity, you're talking about positive values. Anything between -6 and -5 is negative. Okay, so again, you start at the right side, the furthest right, and you work your way backwards. And the reason is, whatever this term is over here, this could be x to the 17th power. If it's positive x to the 17th, your furthest right will always have it going up. If it's negative right here, then it has to be opening opposite. Okay, and it stands true for all of it. And it's a big idea. It really is a big idea. Okay, so now we are away from our parabola. So the best thing to go on these is I'm going to do this. What did I do? Just move the 24 over, right? Do you remember your rules of these? Why did the sign flip? Wait. That's a 12 right here, I'm sorry. I divided everything by 2, but I divided everything by -2. So now my sign flipped. Agreed? Let's factor this. So I'm going to get x plus 6, x minus 2. Is that okay? So this yields me -6. This positive 2. Good. All right. So I want to show where we are dealing with negative values. So I'm going to start way over here. This parabola here was that. When I change the sign, I get down to this. So I'm positive over here because I'm basing it off of this parabola. In between them, it would be below, so that's negative, and positive over here. You're done.
That's awesome.
Well, there's going to be a case where we're eventually going to get to that's going to move things up. That's called the double. Okay? So let's try this one. 4 minus x, 4 plus x. That's the difference of 2 squares. Greater than 0, you're talking about positive. So I have -4 here. I have +4 here. This was an upside down parabola. So over here it's negative. This is positive. This is negative. So where was this value positive? Between -4 and +4. Rounded brackets if you put it in interval notation. Because this parabola would look like this. Okay. Doing okay? So a newer concept. It's okay if it's making your head think a little different. That's normal. But I just want when you guys get to Mr. Trollinger or Mrs. King's Calc AB class, I want them to be like, dude, Stirrup, you nailed it. Rather than, what'd you teach those kids? I don't know.
Lots of stories.
Dude, don't say that. You're killing me, Smalls. Hopefully I've taught you more than that. Hopefully there's some life lessons. All right. Agree? We can see if we can factor it. I got 3x and x, I know that. We can start guessing and checking a little bit. So to get to 10, 2 on the outsides, 5 here, plus, minus. Did I do that right?
Yeah.
So if I FOIL it, 3x times x is 3x squared. -5x plus 6x is +1x. -5 minus 2. Okay? If you can't do it if you have to go by grouping, that's okay, but we're trying to speed you up. So this is going to give me 5/3. This is going to give me -2. So -2's here. Positive 5/3 is here. This parabola would be opening up. So I got positive, negative, positive. So where are we talking about is greater than 10? Here, over, here, over. There's two regions.
So on a graph it would be like this.
Yeah, it would graph looking like this. So when you're talking about the positive or negative, it's where is it above the x-axis and where is it below the x-axis is really what's taking place.
Okay.
Anyone recognize this as a perfect square? Is that okay? Now eyes up here. This is much different. This is going to give me 3/2 for an answer. There's only one answer. Agree?
Sure.
Okay. Does this parabola open up or down?
Neither.
It opens up. Okay. If you graph this as y equals. Okay.
So it's gonna be positive, positive, positive.
So what's the answer here?
Positive. Positive.
Both positive and positive. What's the answer really here we're looking for though? We're looking for negative. Is it going to be negative anywhere?
No.
No.
No, so
Huh? Huh? Yeah, so this particular parabola actually bounces right here.
So that's above the x-axis, right?
Yes, so it's positive. Okay, so let's figure this out a little bit. Let's figure this out because we kind of have a lot of information out there. I want to make sure we're taking care of it. So worksheet S. Worksheet S, I am totally 100% going to be marking off tomorrow. Okay? I'm going to go over it as well. So if you have questions, that's fine. Worksheet T, we are going to start working on tomorrow as well. That makes sense?
Yes, sir.
Does anyone have any thoughts? My tardy kids, I thank you for bringing me something. Please don't put me in this situation.
I know that's
You're putting me in a bad spot. I love you to death, but please don't put me in that
Don't
way.
worry, it's never happening again.
I love you guys.
Never. Ever.